Identification of significant figures can be done by memorizing few rules. The first rule is all non-zero digits are significant. For instance, in the very first example 192, they all are non-zero, so count all of them and you'll get 3 significant figure. Similarly, in the second one 28.76, ignore the decimal point and you will get 4 significant figure. Third example 3847, all numbers are non-zero, so count all of them and you will get 4 significant figure. The last example 3.2, both are non-zero, count both of them and you will get 2 significant figures. So all non-zero digits are significant is the first rule. Second rule says that all zeros between non-zero digits are significant. For example, 506. There is 0 in between 5 and 6 which are non-zero digits. So you will count all of the digits and you will get 3 significant figures. Similarly, the second number 30.63. 3 is the first digit, 0 is the second digit, 6 is third and 3 is fourth digit. So there are 4 significant figures. 0 was in between non-zero digits, so you will count all of them. Similarly, the last one 69.003, there are 5 significant figures as you will count both of the zeros as they both are in between non-zero digits. Now let's discuss about third rule, which is all zeros after non-zero digits are significant figures in a decimal point. Although in a decimal we don't consider zeros which are after the decimal point, but this is the story of significant figures, so we will count each one of them. We may see the first example, which is 0.630. There are 3 numbers after the decimal point. After 63 there is 0, so we will count that because this is after non-zero digits. There are 3 significant figures in the first example. Remember the first 0 which is in the start of the decimal point, we will ignore that. Similarly, in the second example 1.7500, there are 2 zeros which are after the non-zero digits, so we will count each one of them and they are in. You may be wondering that why do we need to ignore 0 if it is in the start of the decimal point. Here is the answer of that ambiguity, which is the rule which says that all zeros before non-zero digits are not significant specifically in a decimal point. For example, 0.62, you will ignore the 0 because it is in the start of the decimal point and just count the non-zero digits, which is 6 and 2. So there are 2 significant figures. Similarly, the second example, ignore the zeros which are in the start. There are 3 zeros, one is before the decimal point and there are 2 zeros which are after the decimal point but before non-zero digits. So according to the rule, we will ignore all of the 3 zeros and count the non-zero digits which are 3, 5 and 7. So in total there are 3 digits, 3 significant figures. Now we have last rule, which says that the zeros at the end may or may not be significant. Remember, this rule is only applicable for whole numbers. We have 37,580, which is 5-digit number. If I will count each one of them, I will get 5 significant figure. But as per the rule, I can ignore the last 0. So I will get 4 significant figure. Both answers are correct. Now here is one question for you, which is the number 1,43,200 is correct to X significant figure. You are just supposed to tell that how many significant figure this specific number can have. Just think about it and write your answers in the comment section.